Today I am going to show you how to solve a system of linear equations, otherwise known as simultaneous equations, by the substitution method. Say you have to solve the following system of equations using substitution. You need to find the x and y values that make these equations true. There are three main steps to follow. Firstly, solve for either x or y in one equation. Secondly, substitute this value of x or y into the other equation and solve. Thirdly, use that number for either x or y to solve for the other variable. Now we consider the first example. In the first equation there is a y, which is the easiest variable to solve for. Therefore y is equal to 11 minus 2x. We substitute this equation into the second equation to obtain 7x minus 4, open bracket, 11 minus 2x, close bracket, equal to minus 14. We expand the bracket to obtain 7x minus 44 plus 8x equals to minus 14. Keeping all of the x terms on the left-hand side of the equation and moving the numbers onto the right-hand side of the equation, we obtain 15x equal to 30. Now we divide through by 15 to obtain a single value for x, therefore x is equal to 2. Now, we can substitute this value of x into either of the equations to solve for y. As the first equation is simpler, we substitute x equal to 2 into y equals 11 minus 2x to obtain y is equal to 7. Thus, we have solved the simultaneous equation. Now we consider a similar example. I would advise you to pause this video and attempt the question on your own before looking at the solution. For this simultaneous equation, we follow the same steps that we did in the first example. So, rewriting the first equation so that the y terms are on the left-hand side and the x terms are on the right-hand side, we obtain y is equal to 6 minus 2x. We substitute this equation into the second equation to obtain 5x plus 3, open bracket, 6 minus 2x, close bracket, equal to 9. We expand the bracket to obtain 5x plus 18 minus 6x is equal to 9. Keeping the x terms on the left-hand side of the equation and moving the numbers onto the right-hand side of the equation, we obtain minus x is equal to minus 9. Now, we can cancel the minus signs to obtain x is equal to 9. Substituting this value of x into either of the original equations, we obtain y is equal to 6 minus 2 multiplied by 9, which is 6 minus 18, which gives y equal to minus 12. Therefore, we have solved the simultaneous equation. Finally, we are going to consider a much harder example, which is more of an A-star type of question. So, we consider the following system of equations. Firstly, we start by identifying which one of the equations is nicer, so to speak. Clearly, y equal to x minus 3 is a simpler equation. Therefore, we substitute that equation into the first equation to obtain x minus 3 all squared is equal to 2x plus 29. We expand the bracket to get x squared minus 6x plus 9 is equal to 2x plus 29. We move the terms on the right-hand side of the equation over to the left-hand side of the equation to obtain x squared minus 8x minus 20 is equal to 0. To solve for x, we must factorise this expression to be x minus 10, x plus 2 is equal to 0. Hence, the values of x are x is equal to 10 and x is equal to minus 2. We substitute these values of x into equation 2, as this is the simpler equation, to obtain y equal to 7 and y equal to minus 5. So, to conclude, the main steps to solve a system of linear equations are: always start by solving for either x or y in either equation. Then, once a value for x or y is found, substitute this value into the second equation and solve.